This is the firmware explanation video tutorial for Arduino working as Modbus RTU Master for RMCS1120 Hybrid Servo Drive. This is the firmware version 1.1. Version 1.0 was kind of a beta test. So these are the improvements in the version 1.0 and that made this version 1.1. So the basic understanding of this firmware lies into the functions that are used here. So this is the function declaration part of the firmware. There is a regular millisecond delay function, useart init, useart transmit, CRC16 that is basically generating the CRC checksum 16-bit. Read Modbus register. This function reads the registers from the Modbus slaves. Basically it queries to the Modbus slaves to read the registers and sending the start address, this first argument, and the number of registers that it has to read. The third argument in this function is slave address. The fourth one is the RTU function. The next function is write Modbus register, which is having arguments as the start address, the value of register. So in this firmware we have implemented the preset register function. There is a 06 in Modbus. For reading the registers we are having the 03 function, that is the reading the multiple registers. And there is a final function, that is the motor control. So here are the function declarations. There is one more interrupt service routine lying at the end. So in this interrupt service routine, this interrupt service routine triggers when the receive complete interrupt is there. So it works on the FSM based algorithm. It waits for the correct slave address to be read, and when it gets the correct slave address, then it fills the slave response buffer. So let's go to the setup function. In this setup function, we are first of all initializing the FSM useart. Its state is wait. Basically it starts waiting for the correct slave address to become as the slave response first byte. Then there are some basic parameters like variables used here. They are being initialized. Then some output pins are declared and they are set to particular logic levels. Slave response buffer is like set to 0. Each element is set to 0 first. Useart init based on its baud rate. So basically it initializes the useart. Let's go to that. So in useart init, we are setting the baud rate. So here in this particular project, we have the RMCS1120 Hybrid Servo Drive, which is running on 115200 baud rate. In Arduino, what happens is if your baud rate is exceeding 57600, then you have to enable a double speed bit, that is this one, by using this piece of code. Then we are enabling the receiver and transmitter, setting the frame format. There is the 8 data bits, 1 stop bit, and we are enabling the useart receive complete interrupt. The next comes is the useart transmit. User transmit basically has two arguments. There is one pointer and one character length. So in these two arguments we are going to deal with the user transmitting. So to understand the functioning of this firmware, we'll go to the loop function. Basically in every embedded system there is kind of a forever loop function. So here it is. Here majorly we are dealing with a function called read modbus register. In this project we are controlling three hybrid servo drives RMCS1120 by using single Arduino. So we have set a counter 3 over here and we are reading the modbus register. So basically in RMCS1120 what happens is the slave address 81696 contains the motor status. The motor status has total 5 values, but for our orientation we just have to check whether the motor is idle or not. I mean there is the value is 0x04. So in this read modbus register function, by using this read modbus register function, we are going to read just one register. So there is basically a defined constant over here. There is one register, and we are reading the motion status address, that is the 8196, and we are giving the function called 0x03. So it starts with the motion status address, that is 8196, and reads one register. Now let's go to the definition of this read modbus register function. This function has 4 arguments, namely register read start address, number of registers to be read, slave address, and RTU function. Based on its input arguments, it sets a master query array and then it transmits it using the user_transmit function. This master query array would always be of 8 bytes. So that's we have put the number of bytes, I mean the character length 8 here. Then it waits for some time. It waits for basically the response from the slave, I mean the correct slave there which is addressing to. So during this delay, the interrupt service routine comes into picture. So it will build the slave response by filling the slave response buffer using the serial in char variable. So after getting the slave response, I mean getting something within the timeout delay, the function checks the slave response, basically processes the slave response. First of all, it checks the slave address, the RTO function, I mean the basic slave response pref that has to be idle one, the regular parameters that it has to check in each and every slave response, and afterwards it checks the CRC 16-bit checksum. If it's correct, then comes the motor status part. So as we are reading just a single register, that is 8196 using this code there, so the fourth element of this slave response would give us the motor status, and to run the motor we need to check this status first. Without this status value being 0x04, we cannot start the motor. So this is the prime condition in this entire firmware. So here it is. Now if it's, let's assume that the current function call of this read modbus registers has given us the motor status as 0x04. I mean the motor is idle. Then it goes to this. The motor control function gets called. Let's go to its definition. The motor control function also has 4 arguments. It has the slave drive ID, it has velocity command, it has acceleration command, it has motion command. So these 3 parameters are the deciding parameters that will decide the motion, I mean the entire rotational and mechanical and accelerated motion of this motor. So you can go through the details of these parameters in the RMCS1120 datasheet. So here we are setting the things, and when the motor control function gets called, it basically sets these values to the registers. There are total 4 registers being addressed here. The first one is the velocity command address, that is lying at 8192. The acceleration command address is 8193, and the motion command address is divided into 2 words. I mean it's basically a 32-bit value. So it basically divided into 2 words, and it sets the number of rotations, basically the motion status, the motion command function, motion command variable. So here it goes. So after settling the parameters using this motor control function, let's go back to the definition of read modbus register again. So after settling the motor control function, the control goes to, the code basically goes to the write modbus register function. The write modbus register function writes a particular value to the defined slave address. It also has 4 arguments: motion status address, then comes the value, slave address, and the RTO function, that is going to be 0x06 by default here. So the motion status address for us is 8196. The motor start command is basically being given by setting the value 0x00 to the register number 8196. So basically this function call starts the motor. So the execution of this firmware is quite simple. Basically we are polling the idleness of the 3 slave drive motors basically, and we are just starting them if they are read as idle. So this kind of a student evaluation project, this can be expanded. The number of slaves can be expanded up to 247 as per the Modbus protocol, and to go through the code, you need to go through this first of all this defined constants. The defined constants will give you the like kind of readability to the code, and the rest of the code is like quite easy to understand, because it like the variable names are quite simple. Whatever the variables are used for, they have been given the same name, and the code basically circulates into the loop only. The code never gets hanged because we have timeouts for each and every error conditions. So this code doesn't hang anywhere during the execution of the system. And in the video of, I mean the project video showing the entire system working with the hardware shows the robustness of the code, because in that video we have disconnected the one slave from the, basically we disconnected the communication of for one slave from master, but still the other slaves were working, and after reconnection even the previously disconnected slave, I'm sorry, so it was working. So this code fits quite well as of now. Still a bit of further improvements needed to be done, and yeah, that's it. And thank you so much. Thanks for listening. It's Tinu.